Hello students, today we will see de Broglie hypothesis for matter waves. We all know that black body radiation, black body radiation, photoelectric effect, Compton effect, these three proved the particle nature of radiation. So black body radiation, photoelectric effect, Compton effect, all these three experiments proved the particle nature of radiation. Earlier, the radiation was thought that it will be of wave nature, but later, this experimental observations of black body photoelectric effect proved the particle nature of radiation. Later on, Compton proved the particle nature of radiation. Yeah. So this is what the thing we know that. But later, in the year 1924, a French physicist, a French physicist by name Louis de Broglie, pronounce it as Broglie, not Broglie. Louis de Broglie. In his PhD thesis, he has hypothesized, he suggested that since nature loves symmetry, if the radiation behaves as particle under certain circumstances and as waves under other circumstances, then one can expect that entities which ordinarily behave as particles to expect to exhibit properties attributable to only waves under appropriate circumstances. So what does Louis de Broglie meant by that is, if radiation can behave as particle under certain circumstances and wave under circumstances, then since nature loves symmetry, particles also which are by physical reality they are particles, they can also exhibit wave nature, wave nature under appropriate circumstances. So what is this under appropriate circumstances? When a particle is at rest, it is a particle. There is no wave. But when particle starts moving, when particle starts moving, then this particle will be associated with waves, associated with waves, and we call these waves as matter waves, matter waves. So since radiation behaves as particles and waves under particular circumstances, under certain circumstances, then particles also behaves as wave under suitable circumstances. What is that suitable circumstance? When the particle starts moving, then it will be associated with waves. So what de Broglie named these particles as matter waves. Okay. So what is this matter waves? Is it a how it is generated? This is how. Is it a mechanical wave which is generated by the disturbances of of material, or is it electromagnetic waves which are generated by the moving electric charges, which is associated with both electric as well as magnetic, perpendicular to each other? Is that as a electromagnetic wave? No, this wave is not even mechanical wave or electromagnetic wave. This wave is a matter wave which is of the type like this. It will be like this. He hypothesized like that. So somewhere the particle will be somewhere in any of these. It can be anywhere. It can be here. It can be there. Anywhere. So we call this as matter waves. We call this as matter waves. So when these matter waves will be there, when particle starts moving, at that time the waves associated with this particle, this is matter waves. So this is what the hypothesis of de Broglie. And the wavelength of this wave, wavelength of this wave is, and the wavelength of this wave is called as de Broglie, de Broglie wavelength, de Broglie wavelength. This is what is called as de Broglie wavelength. De Broglie wavelength. So de Broglie went on prove that when a particle, when a particle, when a particle has a momentum, has a momentum p, has a momentum p, what happens when it starts moving? So there will be a wave associated with this particle. Okay, so a particle which is having a momentum p, which is equal to m into v, then the associated wave having a wavelength, as associated wave having a wavelength lambda is given by is given by is given by lambda is equal to h by p, h by p, where h is equal to Planck's constant, which is equal to what? 6.626 into 10 power minus 34 joule second. So this is the equation for de Broglie wave. So De Broglie suggested that what would be the wavelength of this matter wave. So the wave which is associated with the particle, the wavelength of that particle is lambda is equal to h by p, where p is the momentum. This can also be written as lambda is equal to h by m p, since p is equal to m. So this is what the wavelength expression for the wavelength what hypothesized by De Broglie. So lambda is equal to h by p, or lambda is equal to h by m v. What De Broglie's prediction is concerned with? It is concerned with wave particle wave particle duality. This is wave particle duality. What does it mean? That is the particle nature, particle nature of wave, wave, and wave nature of particle. So since we saw the particle nature of waves, De Broglie hypothesized that since nature loves symmetry, if suppose wave can behave as particle as well as wave under certain circumstances, particle can also behave as particle, not can also, particle will also behave as wave under appropriate circumstances. When it is at rest, it is particle, no wave is associated with that. When particle starts moving, then waves will be associated with that particle, and that particle is called as, De Broglie said, as matter waves. Here in this equation we can see that lambda is what a wavelength which will be associated with a wave, and momentum is always associated with particle. It is always associated with particle. Wavelength is associated with wave. So this expression itself tells us that wave particle. So next we can see the de Broglie wavelength of electrons. Before going to that, let us see what is the relationship between relation between kinetic energy of a moving particle and de Broglie relation between kinetic energy and de Broglie wavelength. So when a particle is moving, the entire energy of the particle is what? Kinetic energy. Entire energy of the particle is what? Kinetic energy. If suppose E is the energy of the moving particle, then it will be equal to what? Kinetic energy, which is given by half mv square, which is given by half mv square. So what is momentum? So momentum is what? Momentum of the particle here is what? E is equal to m into momentum of the particle. Squaring on both sides, squaring on both sides, will get E square is equal to m square. Let us consider this as equation 1. Now this you can write as V square is equal to V square by M square. Substituting the value of V square in equation 1, we can get E is equal to half M into V square by M square. 1 M gets cancelled and to this will become equal to E square by 2 E square by 2 M, or P is equal to square root of 2m into E. So this is the momentum of a particle. P is equal to square root of 2m into E. So this, if you substitute this value of P in de Broglie wavelength, lambda, then lambda m is equal, lambda is equal to h by P. Substituting the value of this P here, then lambda is equal to h divided by root of 2m into 2. This is the relation relation between kinetic energy and de Broglie wave. Kinetic energy and de Broglie wave. Now let us see how we can find out the wavelength of an accelerated electron. De Broglie wavelength, de Broglie wavelength of an of an accelerated electron. Accelerated. So how we can find out the de Broglie wavelength of an accelerated electron? So we have this equation. Let us consider a charge is in between two charged plates. So if it is positive plate, let us consider a charge, positive charge Q plus Q. So when it is near, when it enters this field, enters between these two, and the potential difference between this is between the two plates is what? V. Then what this charge experiences? This charge experiences force towards negative. Then the energy, it gains some kinetic energy. So the kinetic energy for that one, kinetic energy of the charge is E is equal to Q into E is the potential. Due to this potential, and then what is Q? Q is the magnitude of charge, magnitude of charge, and E is E is potential difference. Okay. So this is the energy gained by the charge, or this is the energy which is associated with the moving charge. Okay. Let us consider this as a electron. So if an moving electron, moving electron charge E is equal to 1.6 into 10 power minus 19 coulomb. 1.602 into 10 power minus 19 coulomb is moving, and the mass of that charge m is equal to 9.11 into 10 power minus 31 kg. 10 power minus 31 kg. De Broglie wavelength is what? De Broglie wavelength. De Broglie wavelength is given by lambda is equal to h by p. H by p. So this is what equal to h divided by square root of 2m into p. So the energy of charge, energy of this charge, or the kinetic energy of this charge, E is equal to, here since the charge is E, it will become E to. So in the earlier case it was, so QE, if any charge of magnitude Q, here the charge is what? E, magnitude of the charge E, E to. Let us substitute this value of E in this equation 3. Then lambda is equal to h divided by 2m E into, this is what, the square root. This is what under square root. Since h, m and E are universal constants, universal constants, universal constants, we can substitute the value of h, m and E in the equation 4. The equation 4, then we can calculate lambda is equal to, since v is a variable here, we can take it out as 1 over root of v into h divided by root of 2m into e. That will be substituting the value of this h, m and e. You can write this equation e into what is the value of h? 6.626 into 10 power minus 34 joule second divided by 2 into 9.11 into 10 power minus 31 kg. This is what the value of m into 1.602 into 10 power minus 19 room 19 room. Then we can get the value of 1 over square root of v, that is outside variable. So calculating this, we will get the value of 1.226 into 10 power minus 9. This is what the lambda, unit of lambda is what? Meter. This we can write as lambda is equal to 1.226, or we can, let us write 1.226 divided by root of V nanometer. 10 power minus 9 is what? So this is the de Broglie wavelength or an electron, moving electron or an accelerated electron. This is the equation. This is the equation for, or I will write here, lambda is equal to 1 over 1.226 divided by square root of V nanometer is the nanometer. This is the de Broglie for an accelerated electron. The speed or the energy will be changed, the potential will be increased or decreased. But this will be what? One point constant 1.226 divided by square root of the potential, whatever the potential, while whatever the energy due to the potential of, for that electron will be there. This will be given by the value of this lambda is equal to 1.226 into 226 divided by square root of V nanometer. So this gives the relation for de Broglie wavelength for a accelerated electron.